Hello students, good evening. So we are in the 7th session of this electrostatics force and field. So in Canada we will continue with our discussion. Already session 6 we were talking about the idea of null point. And the null point பத்தி நம்ம பேசிட்டு இருக்கோம். Okay, what is the null point? So if you are looking at a space, if the electric field is 0, okay, so electric field we can also call it as field strength and solala. So if you see this word electric field and solala, we can also use the word field strength. Okay, so if the electric field strength at a location is 0, right, the point is actually null point. Okay, now we were looking at null point for two charges. Q1 and Q2 are two charges. Then because of the two charges, right, null point will be on the line of the charges. Null point will be on the line of the charges. Okay, already nama case 1 paathirukom. What is case 1? If the two charges are like charges. Like charges means rendu charges positive ah irukala, otherwise both the charges can be negative. Appo enna agum? If the two charges are positive or two charges are negative, they may be equal, they may be different also. Okay, enga varum null point? Null point will be coming in the region between the two charges. On the line la they will be coming in the region between the two charges. So already nama last class la enna we have divided, on the line, right, we divide into three parts, A, B, C and solita. So B is the middle and the rendu charges naduvula irukra segment. So the null point is going to come in the region B when the two charges are like charges. If the two charges are unlike charges, one will be positive, other will be negative. Then you know where we are going to find the null point. We will start the today's session. Okay, so I will consider one charge to be positive and the negative. Okay, so this is the line that contains both the charges. Okay, like we will also split this, the full region, the line we will split it into what? Three parts are: part A, part B, part C. Okay, so we will first start with part B only. Part B is the place where the null point will be found when we have two like charges. We have unlike charges, but first we will see. We'll take a point in the part B, and the B region we'll take a point. Okay, so we'll say Q1, Q2. Q1 is what? Positive. Means and the Q1 develop an electric field, right, will be what? Away from the charge. Positive charge if the electric field is generated, wherever you take, and the electric field or direction it will be always away from that particular charge. Okay, in the positive charge field develop the direction of that field will be what? Always away from. Okay, so we have even looked at this representation. What is it? If you have a positive charge, if you look at the directions of the electric field, wherever you see it will be what? Away. So we will say the electric field will be radially outwards and solala. What we can say, because of a positive charge, develop an electric field will be what? Radially outwards. Okay, now what is the second charge? Q2 dana. Q2 is what? Negative. Means because of negative charge rate, electric field generated will be what? Always pointing towards that negative charge. In terms of the diagrammatic representation. Okay, so like this we had, right, so always it will be what? Pointing towards that negative charge. We can say the electric field because of negative charge will be what? Radially inwards. Electric field because of a positive charge is what? Radially outwards. Electric field because of negative charge, it will be radially inwards. Okay, so because of the Q2 negative dana, so it will be what? Towards the Q2. Okay, so this is the electric field too. So E1 and E2 both are in the same direction. Appa cancel aguma? Agadu. The vectors are in the same direction means they will be adding. Ore direction and the parallel vectors. What they will do? They will be adding to each other தானா, so which means what, அந்த region B or அந்த charges நடுவுல இருக்க region தெரியுமா, அதுல we will not get the null point. Okay, so அது முடிஞ்சது. Now our focus will be on what, either region A இல்லனா region C. Okay, so region A ல பாருங்க, region A ல என்ன ஆகும், look at a point. Okay, field because of q1 is what, positive. அப்ப எப்படி இருக்கும், the field developed by the positive charge will be away, அப்படி towards the left side. Okay வா. What about the field because of negative charge, அது எப்படி இருக்கும், the negative charge field will be always towards the negative charge. பாருங்க, the field because of q2 will be towards that. So E1 and E2 are in opposite direction. E1 and E2 are in what, opposite direction. Okay, now the question, will there be a possibility for them to cancel? There can be a possibility, right? And because the two vectors are in opposite direction means when there will be a possibility for them to cancel, when the electric field or the magnitudes, right, when the magnitudes are becoming equal, up and down, they both will be cancelling. Okay, so if for example either 2 Newton per coulomb எடுத்துக்கோங்க, if this is also becoming 2 Newton per coulomb, என்ன ஆகும், both will cancel each other. Okay, now we will look at அந்த region C. இந்த பக்கம் இருக்க region C ல ஒரு பாயிண்ட் மார்க் பண்ணுங்க, mark a point in region C. அங்க என்ன ஆகும், field because of q1 will be away from q1, அப்படி away என்ன, it will be towards that right side வரும். What about the field because of q2 negative தானா, so field because of q2 will be இந்த இடத்துல, this is the point, field will be towards that q2, அப்படி இருக்கும். Here also what is situation we are getting, the two electric fields, they are in opposite directions. So இதுலயும் what is the situation, E1 and E2 are என்ன சொல்லலாம், we can say anti parallel. Opposite னு சொல்றதுக்கு பதிலா what we can say, because they are vectors, right, we can also use the word anti parallel சொன்னா என்னது, they are in opposite directions. Parallel means same direction, ஒரே direction இருந்தா we call it as what, parallel. Opposite னு வெச்சுக்கோங்க, we will call it as what, anti parallel. Okay வா. So in both region A as well as region C, ரெண்டுத்துலயும் there is a chance for the electric field oda value to become 0. But என்ன தெரியுமா, the electric field will not become 0 in both the places. Electric field will become 0 either in the region A இல்லனா region C. ரெண்டு இடத்துலயும் we are not going to have electric field becoming 0. Null point ஒரே இதுல வரும். The null point is not going to come in both region A and region C. எங்க வரும், null point is going to come either in the region A ல இல்லனா region C. So பாருங்க, region A இல்லனா region C. So ஒரே இடத்துல தான் வரும், ரெண்டு இடத்துல வராது. ஏன்னு பார்த்தா, if you look at the charges, okay, so q1 இருக்கா q2 இருக்கா, suppose இதுல ஒரு sample values எடுத்து பார்க்கலாம். q1 ஒரு 1 coulomb எடுத்துக்கோங்க, plus q2 ஓட value -2 coulomb. q1 என்னது 1 coulomb, q2 என்னது -2 coulomb. ஓகேவா. so இப்போ region A ல ஒரு பாயிண்ட் மார்க் பண்ணுங்க, region A ல we are marking a point. okay, இப்போ இங்கல இருந்து we will take the distance as what, r. எதுல இருந்து, from the charge q1. this distance, right, இது ஒரு d ன்னு எடுத்துக்கோங்க. d is what, distance between the two charges. ஓகேவா. so இப்போ என்ன வரும், the field because of first q1 charge, அது என்னது, what is the formula, k into modulus of and the q1 oda value divided by r square dana, which is what, k into 1 coulomb divided by distance என்னது r square. இது அப்படியே இருக்கட்டும், keep it as equation 1. நம்ம E2 ஓட magnitude பாருங்க, E2 magnitude என்ன, k into modulus of -2 coulomb divided by, so q2 ல இருந்து the point is at how much distance, r plus d. total distance என்னது, r plus d the whole square. புரியுதா, what is it, r plus d the whole square. okay, so இதென்ன, k into 2 coulombs by r plus d the whole square. okay, so இப்போ இத நீங்க ரெண்டு எக்ஸ்பிரஷன்ஸ் கம்பேர் பண்ணும்போது you will see something. இந்த செகண்ட் எக்ஸ்பிரஷன்ல நியூமரேட்டர் ஜாஸ்தி, செகண்ட் எக்ஸ்பிரஷன் என்ன, நியூமரேட்டர் என்ன இருக்கா, k into 2 coulombs இருக்கா. அந்த மாதிரியே denominator is also higher. செகண்ட் எக்ஸ்பிரஷன் E2 ஓட மேக்னிடியூட்ல நியூமரேட்டர் இஸ் ஹையர், 2 வருது, இதுல 1 தான். denominator is also higher. denominator என்ன இருக்கா, r plus d the whole square. இங்க வெறும் r square மட்டும், which means what, when the numerator is higher and denominator is also higher, then we will have a chance for that E2 oda magnitude to become equal to E1 for a certain value of r. We will have to find what is the value of r for which we will get the null point. Okay va? So in the region A la theriyuma, we will have a chance of getting the null point. Okay, so just keep it as it is. Now we will go to the other side. So other side நம்ம discuss பண்ணதுக்கு அப்புறம் you will be able to understand exactly what I am talking about. Okay va? So இப்ப என்ன தெரியுமா, forget about the அந்த side A பத்தி, we will just forget about it. இப்ப என்ன பார்க்கணும், we will look at the side C, region C பாருங்க. region C ல அப்படியே we will just mark one point. region C ல we will just mark a point. region C ல we will just mark a point. So அதுக்கு என்ன, I will use a different color marker so that நம்ம carefully பார்க்கலாம். So region C ல we will mark a point. So இங்கல இருந்து let us say the distance என்னது r. இப்ப பாருங்க E2 ஓட magnitude என்ன வரும், k into modulus of minus 2 coulomb divided by இதான the distance என்ன, what is the distance from the Q2 charge to that particular location, r தானா, so r square வருது. Okay, so which is what, k into 2 coulomb by r square. இது அப்படியே நம்ம equation 2 மாதிரி வெச்சுக்கோங்க. 2 எதுக்கு சொல்றேன்னா, because we are referring to E2. okay வா, இந்த பக்கம் வாங்க. So field because of the Q1 charge, அதுக்கு நம்ம என்ன பண்ணணும், k into modulus of 1 coulomb, ஏன்னா Q1 ஓட வேல்யூ நம்ம என்ன எடுத்திருக்கோம், 1 coulomb. okay, modulus of 1 coulomb divided by, so பாருங்க what is the distance of that location from the Q1, இதென்னது, this is a d, அதுக்கப்புறம் இந்த பக்கம் r, so r plus d the whole square வருது. so what is it, k into 1 coulomb by r plus d the whole square. okay, so இதென்ன equation 1 னு வெச்சுக்கோங்க. now when you compare both these terms, you will see something interesting. அந்த எக்ஸ்பிரஷன் 2ல பாருங்க, நியூமரேட்டர் ஜாஸ்தி, நியூமரேட்டர் என்ன இருக்கா, 2 வருது. okay, denominator is lesser. why, second expressionல what is the denominator, வெறும் r square மட்டும். first expressionல what is the denominator, r plus d the whole square. அப்ப என்ன தெரியுமா, இந்த second expression numerator is higher, denominator is lesser. எதோட கம்பேர் பண்ணும்போது, when you are comparing this with the expression 1, அப்ப என்ன ஆகும், ஒரு டேர்ம்ல numerator is higher, denominator is lesser. for example பாருங்க, if I have to look at, I'll give you two ratios. 5/3 ஒரு ratio, ரெண்டாவது 7/2. I'll ask you which is higher. அப்படி கேட்டா what is the quickest conclusion, ஒன்னு you can convert them into decimal place and then tell. இல்லைன்னா நீங்க அப்படியே கம்பேர் பண்ணும்போது எப்படி, how do you compare both these ratios பாருங்க, ஒரு பக்கம் இருக்கா 5/3, இங்க ஒன்னு 7/2. கம்பேர் பண்ணுங்க, இங்க என்னது, numerator is higher, இதுல 5 அதுல 7. ஓகேவா, அந்த மாதிரி denominator is what, lesser. when a particular ratio or a fraction, numerator is higher and denominator is lesser, right, அதோட value will be what, always higher. அப்படிதானா, அந்த 7/2 ஓட value will be always higher than 5/3. அப்ப என்ன தெரியுமா, இந்த E2 ஓட magnitude will always be higher value than E1 magnitude. means what, yes, both these electric field direction பாருங்க, E2 and E1 will be opposite directionsல இருக்கும், but E2 ஓட magnitude will be always higher than the E1 magnitude. அப்போ they will not be able to cancel each other. அப்ப என்ன ஆகும், they will not be able to perfectly cancel each other. so electric fields are in opposite directions, but on the regionல null point வராது. okay, now I will tell you what is the reason behind it. ஏன் தெரியுமா, because when you are closer to that higher magnitude charge, இதுல நான் 1 coulomb minus 2 coulombs அப்படிதானே நம்ம எடுக்கிறது. so region C என்னது, if you look at region C, right, what is region C, region C is a place where we are closer to the higher magnitude charge. higher magnitude charge என்னது, minus 2 coulombs. okay va, when you are closer to that higher magnitude charge, When you're closer to the higher magnitude charge, what happens? The field magnitude because of the higher magnitude charge will be always higher. The two fields will be in opposite directions, but they will not cancel. Okay, va? If you look at this one, the region A, paranga, you are closer to what? Lower magnitude charge. Then there will be chance for both these, the modulus of E1 and modulus of E2. Nama the first case discuss pannikku theriyuma, modulus of E1 and modulus of E2 to cancel each other. Okay, va? So final conclusion, when we have two opposite type of charges, then the null point will not happen between the two charges. And the rendu charge naduvula irukra region theriyuma, adula null point varadu. Clear? Enga varum? It will come on the side and the baka, which is closer to the lower magnitude charge. Idhula paranga 1 coulomb than a lower magnitude. Lower magnitude charge enadhi? Idhula 1 coulomb. Idhula minus 2 coulombs. Nama edhu pathi pesurom? Verum magnitude mattum. Charge oda value mattum. So the null point will be happening on the side closer to the lower charge value. Okay, va? Appaditha varum the null point location. On the side lenna, the region C lenadhi, the electric fields are in opposite directions, but their magnitudes can never become equal. Edinala we already seen that. What is the reason? And the electric field expression patha, one electric field will be always higher than the other electric field. Okay, va? Now you will have a doubt. Enadhi, sir, okay, you said no opposite charges. Null point will come on the region which is closer to the lower magnitude charge. Ipo na oru sample kaamikirukken paaruங்க. So idu oru 2 coulombs nu edukonga. Idu oru minus 5 coulombs. Takkan solunga enga oru null point. Where will get the null point? Null point will come enga varum. So idu ippadi neenga split panna, split it right. Idu enadhi region A, region B, region C. Enga varum? Region B la varadu. The rendu charge nadula varadu. Enna these are what? Unlike charges. The null point will come on the side which is closer to the lower value of charge. Ipo paranga 2 coulombs and minus 5 coulombs. Adala lower value of charge enadhi? Idana 2 coulombs and lower value charge. So in the bakka varum region A la varum null point. Okay, va? I'll give you one more. Idu paranga, if you have 6 coulombs and minus 2 coulombs nu edukonga. Enadhi 6 coulombs minus 2 coulombs. Ipo enna agum? Region B la varadu. Idhila appadidana, unlike charges, region B la null point varadu. Enga varum? It will come on the side closer to the lower value charge. Enadhi? Idanna 6 coulombs dana, idanna minus 2. Edu lower value of charge? Minus 2 coulomb. Idhila nama enna sollirukom paranga, lower value of charge. Already I told, when we look at the charges, right? Ipo just because I say idu paranga minus 6 coulomb and 4 coulomb, it is not like 4 coulomb is a higher value of charge and minus 6 lower. Appadi kediyadu. Minus edukku nama use pandrathu, we are using just to tell this is the different type of charge. Avladha. The minus nama comparison la kondu varakodadu. So minus is representing what? The type of charge. We are comparing the value of the charge. Inga parunga, which is the lower value of charge? Minus 2 coulombs dana, that is the lower value charge. Idhula nama value mattum paakanum. We should just look at the value. So ipo null point enga varum? Null point is going to come on the side closer to the lower value charge. Okay, va? In the region la varum, region C la varum. In the combination la. Okay, va? So this is how we look at the null point location on the line having two unlike charges. Okay, ipo ingonu doubt varano. What is it? Sir, okay, if you are having unlike charges, we said null point will be coming enga on the side closer to the lower value charge. If you have a situation, inga paranga, idu oru 1 coulomb, inga anadi minus 1 coulomb, equal value but opposite. Rendu charge value na numerically they both are equal, but nature wise they are opposite, unlike charges da. So ipo enna agum? Where we are going to get the null point? Ipo enna theriyuma? We will not get null point in any measurable distance la varadu. So measurable distance la we will not be able to get null point. So null point measurable distance la varadu. Enga varum? Measurable distance la varadu anu sonna, where we will have null point. Remember, for any charge arrangement, if you go to infinite distance, and electric field value annagum, it will be what? Always 0. So null point will be what? null point will be only at infinity. Okay va? So verum on the infinity la mattum we'll have null point. Okay, if the two charges are unlike charges and equal value inga madri, like 1 coulomb and minus 1 coulomb appadi irundha, then we are not going to get the null point in any measurable distance. Okay, so the null point will be only at what? Infinity. Okay va? So this is what is the idea of getting null point due to the unlike charges. Okay, so all these are important for the NEET examination point. Nariya edathila enna theriyuma, we will get straight appadiye reasoning questions la we'll have a lot of scope. Like they will give us two charges, ask in which region we can have null point. Okay, sometimes they can ask us the reasoning questions kekala, or they can even ask us the numerical questions. Numerical question enna theriyuma, they will be asking us the good Aditi. Okay, so they will be asking us to locate the null point, exact location of the null point appadi varala. So paranga, we just look at one question. Two charges, values enna q and 3q, rendu positive da. Q charges q and 3q are kept at a distance d apart. Appadi enna, they are kept at a distance d apart. Okay va? And the nadula irukra distance enna d. What is the distance of the null point from the charge q? So first the problem begin பண்றதுக்கு முன்னாடி இதுல என்ன, what are the two charges? Like charges தானா, q and 3q. On top of it they are saying both are what? Positive. Like charges. Like charges இருந்தா எங்க ஒரு null point? Null point is going to come in the region between the two charges. இங்க நடுவுல வரும். It need not be midpoint. It will be coming in the region between the and the ரெண்டு charges நடுவுல. It will not be the midpoint, but it will be in between somewhere. Okay va? Now we have to find in the distance. In the distance நம்ம calculate பண்ணலாம். So what is the distance of the null point from the charge q? And the charge q la வந்து we have to find what is the distance of the null point. Okay, on the distance தான நமக்கு வேணும். So let us say in the distance oda value x னு வெச்சுக்கோங்க. So we are required to find what is the distance and the null point of the distance from the charge small q. On the distance x னு வெச்சுக்கோங்க. அப்ப இந்த பக்கம் what will be the distance? Total separation between the two charges another d. So in the bakka, if you are saying x means this will be what? D minus x. In the side, if you are calling it as x and sonna, then what is the other side? It will be d minus x dana. Enna totally namakku it should be d value. So ipo parunga, electric field because of q will be like this. Enna q is the positive charge. Electric field because of 3q will be, both will be in opposite directions. Okay, ipo enna theriyuma, we will find what is the electric field because of q, adoda magnitude. What is it? K into modulus of q divided by distance another, distance from the charge to the point, x dana, x square. Idhula modulus nama poda thevilla enna, because they are clearly saying q is positive. So kq by x square. Okay va? Idu nama equation 1 vechukonga. Aprom we will look at what is the field because of the 3q, the 3q charge or electric field at that same location. Because we have to compare the electric fields at that location only. Adanade k into modulus of 3q divided by, for 3q landu what is the distance to that location enade d minus x dana. Okay, ipo parunga, idhile namakku and modulus thevilla ena, because that is also what? Positive charge dana. So d minus x the whole square. Idanade equation 2 vechukonga. Now when we will get the null point at the particular place, the point P, let's call it as, when the point P will be null point, eppo the null point agum, when both these electric fields already and the rendu electric fields direction is opposite. When it will become null point? When the electric fields cancel each other. Adukana what is the condition? When two vectors will cancel each other, when they are in opposite directions and their magnitudes are equal. Okay va? Magnitudes equal agadhukku what is the relation we have to express? And the first equation of the value k cube x square should be equal to what? Second expression, what is it? K into 3q by d minus x the whole square. Okay, ipo idhula k cancel pannunga, q cancel aadichi, cross multiplication enna varum? D minus x the whole square is equal to what? 3x square. Enadhu? D minus x the whole square cross multiply panna enna varum? D minus x the whole square is equal to what? 3x square. Okay va? இதுலேருந்து we'll have to just to do the final steps. இப்போ இதுலேருந்து நமக்கு என்ன வரும்? x வரும். X will be coming in which value? X value is going to come in d. அந்த d ஓட termsல வரும் x value. Okay va? So இப்போ பாருங்க. So I can write like this, d minus x the whole square. இதெல்லாம் என்ன தெரியுமா? These are all the numerical simplification techniques. இந்த 3x square நம்ம எப்போ எழுதலாம்? We can write it as what? எப்படி எழுதலாம்? root 3x the whole square. So அதுலேருந்து d minus x can be written as what? Plus or minus root 3x. அப்படிதானா? If we say a square is equal to b square, அதுலேருந்து we can say a is equal to what? Plus or minus b. So இப்போ பாருங்க, d is equal to இந்த minus x அந்த பக்கம் போனா it will be plus x. X plus or minus root 3x. 1 plus or minus root 3. பாருங்க, d divided by 1 plus or minus root 3 is equal to x. அதுதான் x ஓட வேல்யூ. என்னது? d divided by what? 1 plus or minus root 3. Okay va? So இதில் என்ன தெரியுமா? We'll get two values of x. பாருங்க, one will be what? d by 1 minus root 3. ரெண்டாவது d by 1 plus root 3. இதில் என்னன்னா, because if you look at 1 minus root 3, root 3 ஓட வேல்யூ என்ன? What is the root 3 value? Root 3 is 1.732. Means the 1 minus root 3, the total value will be coming negative. அது நமக்கு acceptable கிடையாது. ஏன்னா because we are looking at x as the what distance. So we will only consider one value of x. என்னது? x is equal to d by 1 plus root 3. X oda value on x is equal to what? D by 1 plus root 3. Okay va? So this is the value of x that will be acceptable to us. ரெண்டாவது we will not accept it. ஏன்னா because that is giving us the value of x to be negative. Okay. So this is how we will approach the question. Null point questions. And I'll tell you one more important thing. I think you have to keep this in mind very carefully. Sometimes here I didn't give you the options. The question and on the options kudukala. But if in the examination you are having the options given, okay, so now I'll give you the options. Okay, because the reason I didn't give the options is I wanted to explain the procedure to you. Adukapram I thought I'll give you the options. Okay, inga parunga, if you are having the options like this, okay, so we got the answer. Another x is equal to what? D by what is it? D by 1 plus root 3. Okay. So in the options paranga, I am giving the options. D by root 3 minus 1. Okay. D into root 3 plus 1. These are all the options. Okay va? D into root 3 minus 1 by 2. None. Okay. So paranga, what are the four options they are giving us? D by root 3 minus 1. Rendavathu D into root 3 plus 1. Option C enna? D into root 3 minus 1 whole divided by 2. Option D enadhu none. Idu paatha udane lot of us will get an idea. Enadhu? Okay, namakku vanda answer enna? D by 1 plus root 3. Idu nama ingonnu maadhiri eludala. Enadhu? D by root 3 plus 1. பாருங்க, ஆப்ஷன்ஸ்ல இருக்கா? இல்லையே. ஆப்ஷனே கிடையாது. ஆப்ஷன் பி ஏன்னா அதுல ரூட் 3 பிளஸ் நியூமரேட்டர்ல வருது. ஆப்ஷன் சி நாட் மேட்சிங். ஸோ லாட் ஆஃப் அஸ் வில் திங்க் ஓகே ஆப்ஷன் டி நன் ஆஃப் தெம் சொல்லிட்டு அப்படியே டிக் பண்ணி வில் கம் அவுட். பட் வி ஹாவ் டு பி கேர்ஃபுல் whenever you get answers like this. இந்த மாதிரி இது என்ன தெரியுமா? irrational terms. அந்த root 3 root 2 அந்த மாதிரி வரும்போது we will call it as what? The irrational terms. இப்படி வந்தா if you are not able to find the correct option and the கொடுக்கிற 4 optionsல you are not able to match exactly, அப்ப டக்குனு you should be thinking about one thing. What is it? Can we rationalize? அப்படி பண்ணலாமா? what do you mean by rationalizing? பாருங்க, என்னது? root 3 plus 1 தானா? multiply numerator and denominator by root 3 minus 1. Multiply numerator and denominator by what? root 3 minus 1. அப்படி பண்ணா என்ன ஆகும் பாருங்க? d into numerator என்ன இருக்கா root 3 minus 1 denominator la it's like what a plus b into a minus b. A plus b into a minus b என்னது a square minus b square தானா, which is a square என்ன root 3 square which is 3 minus b square means 1 square which is 1. பாருங்க d into root 3 minus 1 by 2. Is it matching? Yes, right. என்னது, which is our option C. So whenever you get these irrational type of answers right, if you are not able to find the correct option matching, just ஒரே ஒரு thought. What is it? Can we do the rationalization and check? அப்படியே அந்த rationalize பண்ணி you have to check whether the answer is matching or not. அது மட்டும் you have to keep in mind. ஏன் தெரியுமா, these are all the things that we have to be careful while when it comes to solving question in the competitive examination. இதே ஒரு regular board exam என்ன தெரியுமா, whatever answer you get, the x oda value is coming as what, d into root 3 minus 1 by 2 and சொன்னா அப்படியே you can just leave it. But when you are coming to the MCQ type of examination, especially NEET la, you have to match it to the correct answer, right? அப்போதான் நமக்கு அந்த +4 வரும். So when you are not able to find the exact match, what is the thing that we need to be keeping in mind? Can we rationalize பண்ணி பார்க்கலாமா? Okay va? So this is an important thing, just make a note of it. Now electric field in a conductor. Electric field in a conductor. Okay, so already conductor other introduction நமக்கு வந்தது எங்க, when we are talking about the basic idea of the charge. Okay, talking about the basic idea of the charge, adula we talked about what is a conductor and what is an insulator. அங்க நம்ம என்ன சொல்லிருக்கோம், conductor will be able to easily allow the charges oda movement. Conductor will be able to easily allow the charges to flow through it. Insulator என்னது, it will not allow the easy movement of the charges. But இங்க என்ன தெரியுமா, we are going to talk about the electric field in a conductor. We're going to talk about the electric field in a conductor. Conductor can example, best example என்னது, we can take metals like copper, aluminum, silver, இதெல்லாம் நம்ம conductors தான். Okay, so இப்போ பாருங்க, if you have conductor which is like a metal block, okay, இதுல you apply some electric field. இதுல என்னது, we are applying some electric field. எப்படி, like from the left side to right side we are applying electric field. அதனால என்ன ஆகும், remember what is a conductor. conductor குள்ள என்ன இருக்கும், conductor குள்ள there will be what, these free electrons which we also call them as what, mobile electrons ன்னு சொல்லலாம். What is it, free electrons or mobile electrons, they can freely move. Okay, chemistry you will talk about it, metallic bonding ன்னு சொல்லிட்டு. Okay va? So the free electrons or mobile electrons, right, நம்ம அந்த electric field apply பண்ணிருக்கு தெரியுமா, because of the applied electric field these electrons are what, negative charges. Electrons are what, negative charges. So how they will experience the force, remember negative charges. பாருங்க, what is the force formula, force on a charged particle என்னது, force is equal to what, charge times electric field தானா. So if you have a charge q, அதுக்கு மேல what will be the force acting on the charged particle, q times electric field the location. அந்த இடத்துல whatever the electric field is there, right, electric field அப்படியே நம்ம மல்டிப்ளை பண்ணணும், அதுல இருந்து we will get the force. Okay, so இப்போ பாருங்க, the negative charges, right, they will experience a force opposite to the electric field. அதனால என்ன ஆகும்னா, these electrons they will start moving because they are experiencing force, right, they will start moving in the direction opposite to the electric field. அப்படியே if the electric field is towards the right side எடுத்துக்கோங்க, then inside that conductor the mobile electrons are there, no, they will start moving in the opposite directions. அதனால what is going to happen, in this side, in the extreme la, you will see lot of accumulation of the negative charge. இந்த பக்கம் என்ன வரும், you will have accumulation, ஏன்னா electrons எல்லாம் இந்த பக்கம் வருது, so we will have accumulation of the negative charge. So opposite side la they are all coming, so the other side will be what, predominantly it will be having positive charge. இதுக்கு என்ன தெரியுமா, we will call it as redistribution of charge ன்னு சொல்லுவோம். What do you call it as, redistribution of charge. இந்த electric field நம்ம cancel பண்ணா உடனே அந்த charges எல்லாம் they will go back. So when you cancel the electric field, they will just go back to the original place. Applied electric field இருந்தா, when you apply some electric field, and the electric field இருக்கிறதுனால there is an force that the electrons will experience. because of the force there will be what? Redistribution of the charges. Okay, wow. Now electric field in a conductor, right? We are going to discuss based upon this idea of and the idea redistribution of the charges. Okay, wow. So first point paranga, electric field inside a conductor will be always zero. எதுக்கு zero ஆகும்னு சொல்லிட்டு we'll discuss it now. But electric field, இப்போ you take any conductor, right? அந்த conductor குள்ள electric field will be always what? Zero. எப்படி zero ஆகும்னு சொல்லிட்டு we look at it. பாருங்க. Same. Take a metal block. This is like a conductor. நம்ம என்ன we are applying some electric field. Okay. So இதுக்கு நம்ம E external போடலாம். So this is the external electric field or the applied electric field. Okay. Now inside the metal enna agum, because there is electric field, the irukra electrons ella they will start redistributing, right? Adanal we will get in the bakka enna varum, full negative charge varum, accumulation of the negative charge. Opposite side la we will have what? Accumulation of the positive charge. Idhukku nam enna sollirukom, we said this is what? Redistribution of the charges. Okay. Now paranga, what is going to happen because of this? ஒரு நிமிஷம் just forget about this applied field. இதுல மட்டும் பாருங்க, இந்த பக்கம் என்ன இருக்கா? நெகட்டிவ் சார்ஜ், அந்த பக்கம் பாசிட்டிவ் சார்ஜ். Because of this charge redistribution, because of the charge redistribution, and the charge redistribution ஆகிறதுனால we will get one more electric field. எப்படி? Because this side you have positive charge, that side you have negative charge. Will there be electric field or not? There will be electric field, right? Electric field will be like what? It will be on the positive charge towards the negative charge. Because electric field will be always away from the positive charge towards the negative charge. So because of the charge redistribution inside that conductor or metal, there is one more electric field that is produced. Idhukku enna theriyuma? We will call it as induced electric field and solvom. Adu eppadi irukum? It will be exactly opposite direction. Paranga, applied electric field or external electric field is right side, and the induced electric field will be exactly always what? Opposite direction. It will be what? Towards left. And inside the conductor, now you take any point. Inside the conductor you take any point. Okay. If I ask you what is the net electric field and sonna, if I ask you what is the net electric field, okay, what you have to say? The two electric fields are in opposite direction, right? So for example, the external electric field value is higher in Konga. So what will be the net electric field value? It will be what? And the external electric field magnitude minus induced electric field magnitude. Adana higher value minus lower value. Both are anti-parallel, right? So we have to say higher minus lower. Okay. Now understand this carefully. Inside the conductor, if there is a net electric field, the net electric field irukana, then the electrons will keep moving. If there is a net electric field inside the conductor, net electric field irukana, because of that electrons will keep moving. Electrons move on, what is going to happen? This side the negative charge value will keep increasing, and the back of the positive charge value will keep increasing, till when the electrons will keep moving till inside the conductor net, and the net electric field value is becoming zero. Charge redistribution will keep continuing till when? Till the induced electric field is able to balance the applied electric field. So say for example, nama external electric field initially nama edukra value 10 Newton per coulomb edukonga. Initially induced field irukadu initially, because there is a fresh conductor, right? Induced irukadu. Induced will be what? Zero. And the charge redistribute agumbodhu induced value will keep increasing. Eppadi? It will come from 0 to 1, adukapram 1 to 2, 2 to 3, apdiye increase aite varum. It will increase till it becomes 10. Appo enna agudhu? Inside that conductor the net electric field will be what? Zero, because the external electric field or the applied electric field and the induced one, they both are cancelling each other. Because of that, inside the metal or conductor, the electric field will be what? Zero. And this is happening why theriyuma? Because a metal or a conductor will have large number, எதனால? Because it will have a large number of free electrons. நம்ம என்ன சொல்லிருக்கோம்? The electrons will keep redistributing till the induced electric field or the value is matching the applied electric field or the external electric field. Means theoretically என்ன தெரியுமா? We should think of infinite number of charges present inside the conductor. Like இப்போ நம்ம applied electric field 10 Newton per coulomb எடுத்துக்கோங்க. Induced value will also become 10 and stop. Applied 20 எடுத்துக்கோங்க. Induced value also becomes what? 20. Applied is 1000. Induced also will become 1000. Applied is 1 lakh. Induced also can become what? 1 lakh. Because theoretically நமக்கு assumption என்ன? We consider that conductor or metal will have large number, very large number of these free electrons, so that and the redistribution keeps happening till that induced electric field or value is matching the applied electric field or the external electric field. Okay va? Adanala whenever you take a conductor, whether the conductor is in isolation, means adukku pakkathula there is nothing else. Conductor isolation irundha field inside is anyway zero. But even if conductor is present with some surrounding charges inside the conductor, always the electric field or the value will be what? Zero. Because in conductors there is going to be the phenomena called as what? Redistribution of the charges. Adanala we'll have what? Always inside the conductor the net field will be zero. Apdi agalanna the electrons will keep moving further. See, the electrons will keep moving till the induced field or value is matching the applied field. Till then redistribution keeps happening. Okay, adukku what we should have? We should have large number of free electrons. Nam assumption enadhu? We are saying that the conductors will have theoretically infinite number of free electrons. Theoretical assumption. Adanala whatever the electric field you apply, redistribution of these electrons will balance that applied electric field. Okay va? Idu pathi nama thirupi pesa porom eppadi theriyuma? We'll talk about it when we go to the dielectric materials. When we go to the dielectric substances, right? Again we will discuss about this induced electric field. Okay va? So this is the story of why inside a conductor always the electric field value will be what? Zero. Okay. Now rendavathu parunga, electric field near the surface of a conductor. இப்போ ஒரு கண்டக்டர் சர்ஃபேஸ் இருக்குன்னு வச்சுக்கோங்க. this is the conductor surface. இது என்னது? This is the surface of conductor. அது ஃப்ளாட்டா இருக்கலாம், இல்லைன்னா it can be what? It can be even curved. It can be a flat surface, இல்லைன்னா it can be even what? Curved surface. Electric field near the surface of a conductor, this is also important point, will be normal to the surface of the conductor. எப்படி இருக்கும்? ஏன்னா இப்போ பாருங்க, இது நம்ம மெட்டல் ஆப்ஜெக்ட் எடுத்துக்கோங்க. திஸ் இஸ் த மெட்டல் ஆர் த கண்டக்டர். அதுக்குள்ள ஃபீல்ட் இருக்காது. இன்சைட் தி கண்டக்டர் ஃபீல்ட் வில் நாட் பி தேர். when you come to the surface, right, அங்க எப்படி? the electric field will be normal to the surface. Okay, so எப்படி இருக்கும் பாருங்க, it will be like this. electric field near the surface will be what? normal. இங்க எப்படி வரும்? normal. இங்க எப்படி? normal. electric field will be what? always normal. Okay va? inga parunga curved surface. curved surface kenna? the normal oda orientation keeps changing. normal oda orientation, right? neenga appo tangent draw pannanum. enga namakku and normal venum anga tangent draw pannanum. tangent oda direction we have to take the perpendicular. appadi dana? so parunga ipdi normal oda orientation keeps changing. the orientation of the normal for a curved surface will be what? keeps on changing. But electric field பாத்தீங்கன்னா it will be always what? normal to the surface of the conductor. ஏன் இப்படி இருக்கணும்? why we should have the electric field always normal to the surface of the conductor? ஏன் தெரியுமா? இப்போ I'll just give you the argument in the other direction. suppose electric field is having a component parallel to the surface. நம்ம என்ன சொல்லிருக்கோம்? we said the electric field near the surface of the conductor should be only what? normal to the அந்த conductor surface normal தான் இருக்கணும். but counter எப்படி இது prove பண்றது? I'm saying, let us assume நீங்க ஒரு metal எடுத்துக்கோங்க. for example, assume that electric field is like this. இந்த பக்கம் ஒரு component வரும். இது என்னது? நார்மல் காம்பனன்ட் ஆர் பர்பெண்டிகுலர் காம்பனன்ட். அந்த மாதிரி இந்த பக்கம் ஒரு காம்பனன்ட் வரும். இது என்னது? parallel காம்பனன்ட். இதுதான் மெட்டல் சர்ஃபேஸ். ஓகே, if electric field is having a parallel component, அப்ப என்ன ஆகும்? because there is an electric field along that metal surface, என்ன ஆகும்? அந்த சர்ஃபேஸ் மேல இருக்கிற எலக்ட்ரான்ஸ் என்ன பண்ணும்? they will all be redistributing. how? if the electric field is towards the right side of the surface வெச்சுக்கோங்க, then electrons will keep moving towards the left side. They will move till when? Till the left side becomes totally negative and right side becomes positive. So as a result, we will have what? Tirping you induced electric field also will be what? It will be also parallel to the surface. Induced field also will be what? Parallel to surface. The induced field value will keep increasing till it is able to cancel this one, till the parallel, and the parallel part irukku theriyuma, electric field parallel part, that should be cancelled. Till then the electrons will keep moving. Purida? Like the way we discussed about the electric field inside the conductor. So electric field cannot have component parallel to the surface, and the surface parallel component should not be there. Irundha enna agum? That component will be automatically cancelled. Eppadi? Because on the surface also electrons will be there, right? So they will keep moving in the opposite direction till that parallel component of the electric field is cancelled. So veru in the perpendicular component mattum will be remaining. So electric field near the surface of the conductor will be what? Always perpendicular. In the parallel component varadu. There will be always what? The perpendicular component only will remain. Okay va? So this is how we look at electric field at the conductor. So inside the conductor always electric field will be what? 0. At the surface electric field will be what? It will be normal to the conductor surface. Parallel component varadu. Okay va? Irundha enna agum? The parallel component will be cancelled by the redistribution of the charges. Okay va? Now you will be thinking, sir, idukku evvala time edukum? We are saying, redistribution of charges. Normally nama thought eppadi pogum? Okay, so it might take some or half a minute or illena or 2 minutes or 3 minutes, 1 hour, evvala time edukum? The redistribution of charges, right, will take less than a millisecond. Means பாருங்க, இதுக்கு முன்னாடி கேஸ்ல நம்ம என்ன டிஸ்கஸ் பண்ணிருக்கோம்? inside the metal or conductor electric field is always 0. இப்போ நம்ம t is equal to 0 ல starting time you apply some electric field, external field. ஒரு millisecond குள்ள we will have the induced field generated that will increase the value till it is able to match the applied field. அவ்வளவுதான். ஒரு millisecond குள்ள the entire story will be over. So you will see what? You will not even notice. You will see only that, okay, inside the conductor electric field is always what? 0. That is what you will be able to see. Okay va? Idukku appaditha. The redistribution of the charges will take what? Like less than a millisecond. So we can't even notice that it is actually taking a time. Okay va? So this is about electric field inside the conductor and at the surface of the conductor. Okay. Now we talked about electric field due to the positive charge, Tanya. Electric field because of a negative charge. But generally பாத்தீங்கன்னா you will not have like ஒரு single charge மட்டும் இருக்கிறது கிடையாது. We will have what? ஒரு இடத்துல நீங்க if you marking a point வெச்சுக்கோங்க, அதுக்கு சரௌண்டிங்ல you will have like various charges. எத்தனை charges இருக்குன்னு சொல்லிட்டு நமக்கு தெரியாது. And how the charges are distributed அதையும் ஒரு சில இடத்துல நமக்கு தெரியாது. Because what kind of charges are there in the surroundings and how they are positioned, எங்கெங்க இருக்குன்னு சொல்லிட்டு we will not be able to know. So on the cumulative field concept theriyuma? What is the cumulative field concept? Like we said, if you want to find field at a point, you have to look at what are all the charges nearby. Adu surrounding la what are all the charges? ஒரு charge oda field நம்ம எடுக்கணும். எடுத்துட்டு எல்லாத்தோட resultant. So each of the charges will produce field. நம்ம மார்க் பண்ண லொகேஷன்ல Q1 is going to produce a field. அதுக்கு நம்ம E1 வெச்சுக்கோங்க. Q2 will produce a field. அதுக்கு E2. Q3 will produce a field. அதுக்கு E3. Q4 will produce a field. அதுக்கு E4. இந்த எல்லா fields ஓட vector sum அதுல இருந்து தான் நமக்கு we will get what is the resultant electric field or the net electric field. அதுல இருந்து வரும். But if we are not even sure எங்கெங்க இந்த Q1, Q2, Q3 எப்படி அந்த சார்ஜோட அரேஞ்ச்மெண்ட் இருக்குன்னு சொல்லி நமக்கு தெரியாதுன்னு வெச்சுக்கோங்க, then we will not be able to use this cumulative method. அந்த cumulative method யூஸ் பண்ண முடியாது. We will not be able to use the cumulative method to find out really what is the electric field. அது இல்லாம if you look at the space, ஒரு பாயிண்ட்ல நம்ம எலக்ட்ரிக் ஃபீல்ட் ஃபைண்ட் அவுட் பண்ணனும்னா we said okay, go for that Coulomb's the cumulative approach. But I want to know எப்படி ஒரு region or spaceல how the electric field is distributed. If you want to know how in a region or a space the electric field is distributed, ஒரு பாயிண்ட் மட்டும் கிடையாது, in an entire space or region. இப்ப பாருங்க இந்த போர்ட் மேலேயே, so this is like what, இது ஒரு 2D plane மாதிரி தானா, 2 dimensional plane மாதிரி தானா. I want to know how the electric field is distributed in this entire plane. அதுக்கு one of the it's not a primitive idea, but one of the original concepts to understand the distribution of electric field, எப்படி how the electric field is distributed in a region or space, அதுக்கு one of the original ideas that is used is the concept of electric field lines. என்னது? The concept of electric field lines. Concept of electric field lines என்ன? It is a approach. So it is an approach to understand, எதுக்கு? It is an approach to understand the distribution of electric field in a region. So ஒரு region or ஒரு spaceல how the electric field is distributed, அதை understand பண்றதுக்கு ஒரு approach. That approach is called as what? The approach of electric field lines. Okay, so this is a very tedious approach, தெரியுமா? For us in our syllabus we will see it like a very simple method, but actually to do this it takes a lot of time to draw these electric field lines. என்ன தெரியுமா? We have to really draw these electric field lines. The electric field lines approach is somebody has to really draw these electric field lines. So first we look at what is the concept of this electric field lines. பாருங்க, electric field line என்ன சொல்லிட்டு we look at it. Electric field line is an imaginary line. இது ஒரு real line கிடையாது. It's an imaginary line or a curve. So generally என்ன தெரியுமா, when I use the word line அப்படி சொன்னா what you think? Straight line தான் நமக்கு ஞாபகம் வரும். But this electric field lines can be curve also. Line and சொல்றதுனால don't think that it will be always a straight line. The electric field line can be also curve. Okay va? So this is what, it's an imaginary line. இது ஒரு real line கிடையாது. So we have to draw. It's an imaginary line that we draw through a region or a space, so that it's an important one, so that the tangent at any point, tangent சொன்னா, if you have a curve, இப்படி ஒரு curve இருந்து வெச்சுக்கோங்க, we can draw tangents to the curve. Different இடத்துல we can draw tangents to the curve. Okay, the tangent at any point gives what? The direction of the electric field vector. எப்படி? The tangent at any point gives what? Direction of the electric field vector. அது ஒண்ணு. So we are knowing about the direction of the electric field vector. Okay, I'll tell you how this electric field lines will be really drawn. So என்ன தெரியுமா? So if you have to know what is the direction of electric field, what you will do? You will bring a positive charge. If you keep a positive charge, right, whatever the force direction on the positive charge, it will be what? The direction of the electric field. Okay, இங்க நம்ம positive charge அங்க வெச்சுக்கோங்க, then you know it will experience a force like this. So that will be the direction of the electric field. அப்படியே just bring it to the next location. Say for example it is experiencing a force like this. அப்படியே bring it to this location, experiencing force like this. Bring it to this location. Okay, அப்படி you have to take that positive charge, the test positive charge னு சொல்லுவாங்க. Okay, and the test positive charge ஒரு இடத்துல we have to take it, and what we will do, we will see what is the direction in which the test positive charge is experiencing a force. Okay வா? அப்ப என்ன சொல்றேன் தெரியுமா? All these are what? These are all directions of the electric field. Okay, we have to now draw a curve. So இப்படிதான் actually the electric field lines or curves are drawn. First என்ன பண்ணுவான்? They will take the test positive charge, அது ஒரு இடத்துல வச்சு they will try to find out what is the direction of the force acting on the charge. Direction of the force acting means what? That is the direction of the electric field also. Apdiye they will mark all the directions. Adukaprom, now they will draw the curve in such a way that all these will be what? Eppadi, look at it, I will use a different color marker to draw the curve. Okay, so now they will draw the curve such a way that all these are what? All these are like the tangents. Paranga. All these previously we indicated the directions, right? Adella enagum. We will draw the curve in such a way that all those lines are now what? Tangents. Appudu actually the concept of field line comes. Okay, va? So we will draw the field lines in such a way that tangent at any point on that particular field line or field curve, whatever you call it, gives what? Direction of the electric field vector. And the tangent we draw to that field line means adilandi we can find out what is the direction of the electric field vector. Okay, va? Rendavathu enna parunga, the relative closeness. For electric field lines landu we can comment of the direction of the electric field. For electric field lines representation நம்ம கிட்ட இருக்குன்னு வெச்சுக்கோங்க. அதிலிருந்து we can comment on what is the direction of the electric field at each and every location. அந்த மாதிரி we can also comment on exact அந்த electric field value சொல்ல முடியாது. But we can comment on where the electric field is having a higher strength, means where the electric field is having a higher magnitude, and enga the electric field strength is lesser. So compare பண்ண முடியும். ஒரு ரெண்டு இடத்துல we can compare which place is having a higher electric field strength and which place is having a lower electric field strength. Exact value சொல்ல முடியாது. Like we cannot say that okay, in inga the electric field will be 10 Newton per coulomb. அப்படி value சொல்ல முடியாது. But we can compare the locations and tell where the electric field is going to be higher in terms of the value and where the electric field is going to be lesser. அது எப்படி தெரியுமா? Look at this. The relative closeness of the lines. Relative closeness என்ன தெரியுமா? எங்க lines closed இருக்கும். So wherever the lines are close, at that place the field will be what? Higher. So means when the lines are closer, it means what? The electric field strength there will be what? Higher. When the lines are far apart, when the lines are far apart means they are far away. Appanna, in that particular place the electric field strength is what? Less. Okay, va? So the relative closeness of the lines at a place will give an idea about the intensity of the electric field at the point. Intensity of the electric field and the strength of the electric field. Okay, va? So I'll just show you the representation so that we can clearly understand what this relative closeness means. Okay, va? So this is the concept of the field lines. This is real kadiyadu. It's not like, you know, putting in the plane mela, let's say this, I said this board itself is a 2D plane. Idukku mela, are you able to see any lines? Kadiyade, we are not able to see any lines. But if you want to understand how on this particular board there is electric field anna, we can try and represent the electric field distribution by using the concept of the field lines. And the field lines concept which we can express how the electric field is distributed. Inga parunga, I will show you. Okay, so this is one electric field line edukonga. So at point P namak electric field direction venum. Appo nama enna pannom? Apdiye we should draw a tangent, avladha. So at this point P you draw tangent to that curve. The tangent is going to represent what? It is going to represent the direction of the electric field at that particular location. Okay, va? And the madri ipo namak in the Q edathila we want to know the direction of the electric field. Ipo enna pannom? Apdiye and the Q kitta we have to draw the tangent to the curve. Parunga, tangent draw panna eppadi iruka? It is like this. So adilandi we will be able to know at each and every location or edathila we will be able to know what is the direction of the electric field. Okay, va? Adukapra in the second diagram parunga, the first representation is the second representation. Second parunga, idhula point A and point B நம்ம mark பண்ணிருக்கோம். Point A கிட்ட எப்படி இருக்கா? The lines are closer. பாருங்க, இப்போ if you draw ஒரு unit area என்ன தெரியுமா? Area of 1 unit, 1 meter square in terms of SI unit. ஒரு unit area எடுங்க, அதுல you see that more number of field lines are going through A. Point A la we are having more number of field lines are going. Same area, less number of field lines are going at the point B. Adala the conclusion enna? When the lines are closer, means what? There the electric field strength is high. when the lines are far away, the electric field strength is what? Less. Idhukku enna theriyuma, we can also say it like this. Okay, the strength of the electric field is given by number of field lines passing through unit area. The unit area nam actually அப்படியே அந்த கிராஃப்ல மெஷர் பண்ண முடியாது. It's a way we'll try to analyze it. இங்க பாருங்க, you take some area. In the area la irundhu how many field lines are going at point A? All 3 lines are going. Same area you keep at B, how many lines are going? Only one line is going, right? So compare பண்ணும்போது what is the situation? At point A the lines are closer. Point B kitta the lines are what? Relatively far away. So what we can say, field, what a strength or the magnitude of electric field at point A will be higher than the magnitude of electric field at the point B. Okay va? So ipdi we can compare the strength of the electric field by using what? By using the idea of relative closeness. By using the idea of what? Relative closeness. Whenever the lines are closer means and therefore the field strength is high. When the lines are far away anna the field strength there is what? Lesser. Okay va? So this is the concept of the electric field lines. ஞாபகம் வச்சுக்கோங்க, this is not a real line. இது ஒரு real line கிடையாது. இப்போ எல்லா இடத்துல you will have some electric field, like you know, even the room where I am sitting, நான் உட்கார்ந்த ரூம்ல, or even the place where you are sitting, அங்கேயும் electric field இருக்கும். But do you see any real lines going like that? இல்லையே. So these are the or imaginary lines that we have to draw. They will not exist, we have to draw. So இப்போ நமக்கு ஒரு இடத்துல you want to understand how the electric field is distributed. அதுக்கு in the original days, right, people used to actually draw the field lines and show. இப்படிதான் இருக்கும்னு சொல்லிட்டு they used to draw the lines and then show. But இப்போ என்ன தெரியுமா, we have more advanced techniques. Like we have you know, so there are softwares which are available. அதை வச்சுட்டு if you input some conditions, and the input conditions the software will be able to graphically give us a representation, 3D visualization. எப்படி இந்த electric field இருக்கும்னு சொல்லிட்டு they themselves will be able to give us the 3D visualization. Like that we have some really advancements. இது ஒரு to tell, you know, this is the kind of an old concept மாதிரி, but this is needed for us in the NEET examination. Okay, so நான் டிஸ்கஸ் பண்ண தெரியுமா how to draw. இதோட we'll try to hold the class. How to draw na, how people used to draw the electric field lines. நமக்கு அந்த கான்செப்ட் கிடையாது. We don't have the concept of drawing the field lines, but we should understand how the field lines are actually drawn so that நமக்கு ஒரு clarity கிடைக்கும். Okay, எப்படி, like I said, they will take a test positive charge. They will take a test positive charge. எடுத்துட்டு at different places they will mark what is the direction of the force acting on it, which means what? That is also the direction of the electric field. A positive charge will experience force in the direction of the electric field. And the arrows எல்லாம் மார்க் பண்ணதுக்கு அப்புறம் we will draw a curve. அப்படியே ஒரு curve draw பண்ணோம், which is going to have all these arrows as the tangents. The curve எப்படி, the curve should have all the arrows as tangents. Curve first வரது கிடையாது. So how you draw the field line? First ஒரு இடத்துல you have to take the test charge. எடுத்துட்டு போய் you have to look at what is the direction of the force acting on it, which will be the direction of the field. அந்த எல்லா arrows நம்ம மார்க் பண்ணணும். Actually whoever is drawing the field line, they have to mark the arrows. அந்த எல்லா arrows மார்க் பண்ணதுக்கு அப்புறம் they will draw the curve. இதுதான் electric field line. இந்த ரெட் கலர் இருக்கு தெரியுமா, இதுதான் electric field line. Okay va? So first the field line will not come. First somebody has to take the test charge, எடுத்துட்டு they have to mark all the arrows. அதுக்கு அப்புறம் அந்த arrows எல்லாம் நம்ம tangents கனெக்ட் பண்ண மாதிரி you will draw the electric field line. இப்படி தான் வரும். Okay, so wherever the force is high, so ஒரு இடத்துல the force acting on the charge in high வச்சுக்கோங்க, that means what? The field there will be high. So அங்க என்ன தெரியுமா, the field lines will be drawn more closer. அதுதானா the relative closeness. எங்கெங்க field will be higher, there the field lines will be what? Getting closer. அப்படிதான். So this is how people actually draw the electric field lines. அடுத்த கிளாஸ் என்ன தெரியுமா, we will start with the properties of the electric field lines and also we'll look at some questions. Okay, so we'll continue in the next class.